Hello. Okay, graphing rational functions. So, a rational function, we've worked with rationals before. It's in the form of p of x over q of x. So just some polynomial over another polynomial. So p of x and q of x are both polynomial functions. And q of x just can't equal 0 because you can't divide by 0. You guys should know that by now. So q of x cannot equal 0. And one of the simplest rational function is the reciprocal function. So f of x equals 1 over x. And we've worked with that the past couple sections where we just plug it into our calculator and we graph it. This one's going to be a little bit different. We're not using a calculator to graph these. Okay? Now, an asymptote is a line in which the graph approaches. So the graph is approaching this line. An example of this is in the graph to the right, there's a vertical asymptote at x equals -3, and there's a horizontal asymptote at y equals 1. And if you can't see those, so this is the vertical asymptote right here, x equals -3. Whoops, sorry, that was not very great. But obviously, I moved that over a little to the right, but that is x equals -3, so that's my vertical asymptote. Both of those graphs are approaching that line right there. Okay, now the horizontal asymptote is y equals 1, so that's that one right there. Again, sorry, that wasn't the best line. But, so y equals 1, that's that line right there. Okay, and we've gone over asymptotes. We should kind of know them. Now, a hole is a removable discontinuity or breaker. I can't say that word. I need to figure out how to say it right, sorry. Or break in the graph. So like we have a hole right there on this graph. So if p of x and q of x have a common factor of x minus a, then those factors cancel and there's a hole at x equals a. So if we look at this function, f of x equals x minus 2 over x minus 2 times x minus 1, those x minus 2's cancel, leaving me a hole at x equals 2. Whoops, sorry. Okay, so they cancel, which gives me this hole right there. Okay, we'll get into how to find all this and everything in a second. So to graph a rational function, these are steps that you should probably just follow. So first you're going to rewrite the function, then you're going to find the x-intercepts, find the y-intercepts, find the vertical asymptote. So you find the x-intercepts by finding the zeros of the top. So this is finding the zeros of the top. So first we factor it, and then we find the zeros at the top, and then we do f of 0, so we plug in 0 for x, and then the vertical asymptotes are finding the 0 of q of x, so we find the zeros of the bottom. And then for the horizontal asymptote, so if you didn't get this copied down, I'd maybe write that real quick because it's going to go away because I can't figure this out. Yeah. But, so if the degree of the top, so P is always the top, Q is the bottom. If the degree of the top is greater than the degree of the bottom, there is no horizontal asymptote. Okay? If the degree of the top is less than the degree of the bottom, then the horizontal asymptote is the x-axis, which is y equals 0. Now, if the degree of the top equals the degree of the bottom, then you have to look at the leading coefficient of the top and divide that by the leading coefficient of the bottom. And that's going to be your horizontal asymptote. Okay? And then any holes in the function by looking at common factors. I would actually move 6 to right here. Do that after you factor. That's what I would do. And that's what I'm going to do when I go through examples. Okay? Okay, let's look through this. So if we have f of x equals x plus 1 over x minus 5, that is already factored. So our first step is done. There is nothing that cancels on top and bottom, which means we don't have any holes, which I forgot to write that, but I'm sure I wrote it later. Okay. Now we're going to find the x-intercepts by setting the top equal to 0. So I'm going to set x plus 1 equal to 0. If you don't have room in your little box, I don't know how big these boxes were that I gave you on these notes. I would maybe write this on a separate sheet of paper just so you have everything I write on here, like x-intercept, set top equal to 0. I would write that down. Okay? So x plus 1 equals 0. solve for x, so that's x equals -1, which means my x-intercept is -1, 0. You have to write that as a point, because an x-intercept is where it crosses the x-axis, it crosses at a point, so it has to be written as a point. So that's going to be right there at -1, 0. Okay, now for my y-intercept, I'm going to do f of 0. So I'm going to plug 0 in for wherever there's an x. So that's going to be 0 plus 1 over 0 minus minus 5, which is 1 over -5, which is -1/5. So my y-intercept has to be a point, is 0, -1/5. And that's that point right there. Okay, my vertical asymptote, that's what you get when you set the bottom equal to 0. So I have x minus 5 equals 0, which means x equals 5. So I have a vertical asymptote at x equals 5. Vertical means up and down, so that's going to be right there at x equals 5. Okay, horizontal asymptote, that's when I'm going to follow the rules. So if I look at the degree on top, we just have the x plus 1, so my degree up there is 1, because the exponent here would be a 1, right? The degree on bottom is also 1, because the exponent there is 1, so the degrees are the same. So I'm going to look at the leading coefficient of P over the leading coefficient of Q. The leading coefficient of P is 1. The leading coefficient of Q is 1. Remember, the leading coefficient is the number in front of your highest power. So my highest power there is just x, and the number in front of that is just 1. Same with the bottom, it's just 1. So that's going to be y equals 1. So my horizontal asymptote is y equals 1. Okay, there were no holes. Now, from where I have plotted my points and where I have the asymptotes, I know that this graph goes along asymptotes, okay? So it's going to go along that right there, because it has to cross those 2 points, which means it's in the bottom left quadrant, and then it's going to be kitty corner to it. They're always opposite, so it's just going to be kitty corner to it, and it's in the other quadrant. Okay, for my domain here, that's your x values, and that's going to be -infinity to 5, and then 5 to infinity. My range is y values, so that's going to be -infinity to 1, and then 1 to infinity. Okay? Let's do another one. So if we have 3x plus 3 over x plus 2, I'm going to factor that top. So that becomes 3x plus 1 over x plus 2. Nothing cancels, which means I have no holes. So let's set the top equal to 0 and find the x-intercept. So I have 3x plus 1 equals 0. You could divide by 3, and you get x plus 1 equals 0. So x equals -1. So my x-intercept there is -1, 0, which is that point right there. Now my y-intercept, that's when I'm going to plug 0 in, and I'm going to go back. Whenever you do y-intercepts, I would always go back to your original one. I would plug it into the non-factored one. Non-factored. Okay, it's just a little bit easier. I mean, you'll still get the right answer if you plug it into the factored one. Either way is going to work. I just prefer to plug it into the non-factored one. You do what you want, okay? I suggest you plug it into the non-factored one. So we have 3 times 0 plus 3 over 0 plus 2, which is 3/2. So that's going to be 0, 3/2, which is right there. Now my vertical asymptote, that's where I'm going to set the bottom equal to 0. So I have x plus 2 equals 0, which means x equals -2. That's going to be that right there. Now my horizontal asymptote, that's when I'm going to follow the rules. So if I look at the top, the degree on top is 1. The degree on bottom is also 1. So that's going to be leading coefficient over leading coefficient. Leading coefficient on the top is 3. Leading coefficient on the bottom is 1. So that's going to be 3 over 1, which is 3. So that's going to be y equals 3. There are no holes. Oh, sorry, graph that. No holes. And then again, from my points that I have graphed here, I know that it's going to be on the right bottom quadrant, and then the kitty corner, so the top left quadrant. Okay, my domain here, negative infinity to negative 2, and then negative 2 to infinity. My range, negative infinity to 3, and then 3 to infinity. Okay, let's do another one. So we have to factor this first. That factors to x plus 3, x plus 5, or x minus 5 over x plus 3. Now those x plus 3's cancel. This is where we're finding the whole. This is why I do it first, because if things cancel, it's very obvious that, oh, we have a whole here. Okay, so we have a whole at x equals negative 3, because we're going to take what we just canceled, that x plus 3, and we're going to set that equal to 0, so you get x equals negative 3. That's where that whole comes from. Okay, so we have a whole at negative 3. Now we have f of x equals x minus 5. We need to find out where this whole is at. So once we have simplified this down, we figured out that we have a whole at x equals negative 3. We are going to take this negative 3 and we're going to plug it in to here to figure out what the y coordinate is for this whole. Okay, so that's why I'm going to do f of negative 3 equals negative 3 minus 5, which is negative 8. So we have a whole at negative 3, negative 8, which is right there. Okay, now I can go through and find my x-intercept, y-intercept, blah, blah, blah. So x-intercept set the top equal to 0, so that's x minus 5 equals 0, which means x equals 5, so that's 0, 5, right there. Y-intercept, f of 0, and I'm using my simplified version here. You could use the other version if you wanted to, but I would just use the simplified version. Okay, especially when stuff cancels, go to your simplified version. If something cancels, go to your simplified version. Okay, so we have f of 0 equals 0 minus 5, which is negative 5, so that's negative 5, 0. Vertical asymptote, set the bottom equal to 0. There is no denominator, or it's 1. 1 can never equal 0, so there is no vertical asymptote. Horizontal asymptote, the degree on top is 1. We don't even have a degree on the bottom, so that is greater than the degree on bottom. So again, there is no horizontal asymptote. This is just a line. Okay, so that is our graph right there. It's a line with a hole in it. Okay, my domain here is negative infinity to negative 3, and then negative 3 to infinity. My range is negative infinity to negative 8, and then negative 8 to infinity. Okay, we aren't going to do the last one. I am going to go through it in class. So, and I really am. I know I've said that before, and then we don't do anything in class, but we are really going through this one in class, okay? This is a little bit trickier concept. It's not tricky, but there's just a lot of steps to it. So we are going to go over that last one in class. Sorry it took me so long to make this video. You guys are super awesome for dealing with me, and I appreciate every single one of you. So, yes, you're the best, okay? Remember to take the quiz. Bye.